I am Mrs. Smith. I am a teacher. My students and I would like to play our favorite game with you. It's called the Right-Wrong Game. We play this game so we can learn how to think like a mathematician. A mathematician is a person who thinks about numbers and how to solve number problems. Now, here are my students who will help you play the game.
Hi, I'm Robin.
And I'm Rob.
We love the Right-Wrong Game. It helps us learn a lot about numbers. We are going to teach you how to play the game.
After a teacher asks a question, we will say an answer. We want you to guess if our answer is right or wrong. But be careful, we might try to fool you.
If we say a right answer, you would circle the smiley.
If we say a wrong answer, you would circle the frowny.
Rob, what is this?
That's a cat.
Rob, you are so silly. That's a dog. I'm going to circle the frowny because you said a wrong answer.
Good choice, Robin. I didn't fool you this time. Let's try another.
I have one apple and then get one more. How many apples do I have now?
One apple and one apple makes two apples. You have two apples.
Robin is right. I am going to circle the smiley.
Good choice, Rob.
Okay, let's play.
Remember, if you see us or another student give a right answer, you would circle the smiley. And if you see a student give a wrong answer, you would circle the frowny.
Ready? Here is a practice problem.
How many bears are there?
3 bears. Circle the smiley if you think I gave a right answer. And circle the frowny if you think I gave a wrong answer. Now go ahead and make your choice.
If you circled the frowny, you were right. You were thinking like a mathematician. There are only 2 bears.
Ha ha, I can't fool very many people. Let's try one more.
How many dots are there?
3 dots. 1, 2, 3.
Circle the smiley if you think Rob said a right answer. Circle the frowny if Rob said a wrong answer. If you circled the smiley, you are right. You are thinking like a mathematician.
Okay, here are some more.
In a moment, your teacher will give you a sheet of paper with smiley faces and frowny faces on them. Then, you will see some short videos of children playing the right-wrong game. After you watch each video, decide if the student's answer is right or wrong. If you think it is right, circle the smiley face. If you think it is wrong, then circle the frowny face. Have fun, and thank you for playing.
Now I would like to invite you to join 2 of my students to play the Right-Wrong Game. Have fun! Challenge number 1. Look at these pictures of different dominoes. Which 2 sets of dominoes could represent the number 14?
I don't think it is the first one. It's the last 2 sets of dominoes. They make 14.
Challenge number 2. Here is a number scale. When I place a number problem on one side that is equal to the number problem on the other side, the scale will balance. If I put 2 number problems that are not equal on the scale will not balance. Here are more number problems. Tell me the color of the 2 number problems that are equal and will balance the number scale.
The red and green number problems are equal.
Challenge number 3. Here is another problem. Tell me the color of the two number problems that are equal and will balance the number scale.
The red and blue number problems are equal.
Challenge number 4. Are these statements equal?
No, these are not equal because the numbers are different on both sides.
Challenge number 5. 327 can be represented with 327 ones. This quantity can also be represented with 3 hundreds and how many ones?
7 ones.
Challenge number 6. Here is one way to show the number 132. Each block has 100 segments, so it is equal to 100. There is one block to represent 100. Each long rectangle is a 10. There are 3 long rectangles to represent the 30 in 132. Each cube is a 1. There are 2 cubes to represent 2 ones. Here are some more blocks, rectangles, and cubes. Can you show me a different way to represent 132?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 13 rectangles and 2 cubes. Here is 132.
Challenge number 7. I'm going to show you some numbers. One of them is missing in this sequence. 1, 2, 4. Can you tell me what number is missing?
3.
Here are some more numbers in a sequence. One of the numbers is missing. Can you tell me what number is missing?
238.
Challenge number 8. 2,489 can be represented as 24 hundreds and how many ones?
89.
Challenge number 9. 408 can be represented with 4 hundreds and 8 ones. This quantity can also be represented with 8 ones and how many tens?
There are 0 tens in the number 408.
Challenge number 10. This is part of a hundreds chart. What number is in the gray box?
332.
How do you know that?
Because 321, 331, 332.
Challenge 11. Here is a story problem for you to solve. Martin sold 37 bags of popcorn on Monday. On Tuesday, he sold 23 more bags. How many bags did he sell? Let me read it to you again. Martin sold 37 bags of popcorn on Monday. On Tuesday, he sold 23 more bags. How many bags did he sell?
I know if I take the 3 from 23 and add it to 37, that would make 40. Then if I add the 2 tens from the 20 to the 40, I would have 60 altogether. So it's 60.
Challenge number 12. Here is another story problem for you to solve. The school is having a pencil sale to buy books for the book club. The students sold 138 pencils on Monday. On Tuesday, they sold 72 more pencils. How many pencils did they sell? Let's read the problem again. The school is having a pencil sale to buy books for the book club. The students sold 138 pencils on Monday. On Tuesday, they sold 72 more pencils. How many pencils did they sell?
I know if I take the 2 from 72 and add it to 138, that would make 140. Then, if I add the 7 tens from the 70 to the 140, I would have 210 altogether. So it's 210.
Challenge number 13. Pam baked cookies for a party. She gave 19 cookies to her friends. Now Pam has 11 cookies. How many cookies did Pam bake? Let's read the problem again. Pam baked cookies for a party. She gave 19 cookies to her friends. Now Pam has 11 cookies. How many cookies did Pam bake?
Here is 19. Here is 11. And if I move this here, it's 10. She baked 10 cookies.
Challenge number 14. Can you read this problem to me?
Sure. 35 subtract 12.
How would you solve this problem?
I started at 12 and added 10 to get 22, and then I added 10 more to get 32. To get 35, I need 3 more. I added all of my jumps, 10 plus 10 plus 3, which is 23. So the answer is 23.
Challenge number 15. I'd like to show you another math problem. Can you read this problem to me?
Blank plus 17 equals 28.
How would you solve this problem?
It's 11.
How did you figure that out?
I looked at 28 minus 17. First, I took 8 minus 7, and that is 1. And then I took 20 minus 10, and that is 10. So, 10 plus 1 equals 11. The answer is 11.
Challenge number 16. Please read this problem.
32 subtract 9.
How would you solve this problem?
I know there are 32. If I take one of the tens and make it a 1 and a 9, I can subtract the 9 and move the 1 over. That leaves 10, 20, 21, 22, 23. The answer is 23.
Challenge number 17. Carmen has a rock collection. In the collection, Carmen has 13 rocks. Carmen wants to have 27 rocks before he takes them to school. How many rocks does Carmen need? Let's read the problem again. Carmen had a rock collection. In the collection, Carmen had 13 rocks. Carmen wanted to have 27 rocks before he took them to school. How many rocks does Carmen need?
Carmen needs 40 more rocks. I started at 27 because this is how many he wants to take to school. Then I counted 10 more, and that is 37. And then I counted on 3 more to make my 13, and I landed on 40. Carmen needs 40 more rocks.
Challenge number 18. Jack has 142 cards in his card collection. Jack wants to have 210 cards before he takes them to school to show his friends. How many cards does he need? Let's read the problem again. Jack has 142 cards in his card collection. Jack wants to have 210 cards before he takes them to school to show his friends. How many cards does he need?
I would start at 142 and add 8 to get 150. Then I would add 50 more to get 200. Then I need 10 more to get 210. 50 plus 10 plus 8 is 68. The answer is 68 more cards.